Okay, hello everyone. So today's topic is magnetic effects of electric current and Lorentz force. So today we'll be basically starting our unit magnetism. It is a very important unit with very complex concepts and complex numerical. So what you to do is you to learn the basics very correctly. Okay, so let's move forward and let's start from very basics. Okay, so what is magnetism? So you must have seen that a magnet attracts piece of iron. So do you ever ask questions like why magnet attracts only iron and not copper? Do you ever ask this type of questions? Or do you ever think that what is coming out of a magnet? What is something that is coming out of a magnet that is applying magnetic force on other objects? So do you think about all this or do you only write all this in your notebook? Which kind are you? Because this unit, how will you understand this topic depends on which kind are you, this kind or this kind. So let's learn from the basics how magnetic field is produced, how force is being experienced by different objects due to magnetic field, what is the formula. So everything will be covered in this unit. Okay, so let's move forward. So source of magnetic field. So which particles produces magnetic field? So remember, magnetic field is produced by moving charges. So there are two conditions which should always be there: moving and charges. So charges should be moving to produce magnetic field. Like in first diagram, if you see a positive charge is moving, it is producing magnetic field. A negative charge is moving, it is producing magnetic field. And when someone asks me, like, there's a piece of magnet, a black colored bar magnet, how it is applying magnetic field. So every material is made up of atoms. And what is there inside atoms? Inside atoms, there are moving electrons. So electron is basically what? Electron is a negative charge. So this charge is moving, so it produces magnetic field. So why does only iron or magnet produces magnetic field? Why don't any another object? Because every object is made up of atoms and atoms are moving electrons. Why not all objects produces magnetic field? So we'll learn how different materials produces different magnetic field, how magnetic field can be zero. All these topics will be covered. But the most important thing is that magnetic field is produced by moving charges. Now, magnetic force is applied on moving charges. Now, what does this mean? So, magnetic field is produced by moving charges, and also remember, magnetic force is also applied on moving charges only. So, in first case, the charge is positive and it is moving. So, magnetic force will be experienced by this charge. In second case, there is charge, but it is not moving. So no magnetic force will be applied on this charge. In third case, the object is moving, but there is no charge. So it will also not experience any magnetic force. So for magnetic force to be experienced, it should be moving and it should have charge. Okay, so next important thing is if a moving charge experiences magnetic field, magnetic force, then what is the force? So F is force due to magnetic field and value of this force will be Q. Q is basically the value of charge. If it is positive, put positive. If it is negative, put negative. V is velocity, B is magnetic field. So V is a vector quantity, B is a vector quantity, and there is cross product of two vector quantities. So we have force which is also a vector quantity. Now always remember this is a cross product and A cross B is AB sine theta. So if you have to only find the value of force, then value of force will be QVB sine theta, where Q is charge, V is velocity, B is magnetic field, and theta is angle between velocity and magnetic field. So since force is a vector quantity, so we have already discussed how to calculate value. Now how to calculate direction. So you can even use Fleming's right hand rule. So in Fleming's right hand rule, this our forefinger is velocity, the middle finger is magnetic field, and the thumb is your force. Okay, so either you can find direction with this method or we can also use the vector product method. So I cross J, so you first draw I, J, K and then move in clockwise direction. So I cross J will be K and opposite J cross I will be minus K. J cross K will be I and opposite K cross J will be minus I. And K cross I will be J and opposite I cross K will be minus J. Now always remember when two vectors are parallel, their cross product is 0. So I cross I is 0, j cross j is 0, k cross k is 0. This slide will be very important in this chapter. This vector product method, it's very important in this chapter, because if you solve questions using vectors, then you will get the directions directly, as you have to find out the direction with the help of this method. Now let's solve one numerical. An electron is traveling in positive x direction with velocity v in magnetic field B in positive y direction. Find force acting on charge. So charge is minus E because electron is negatively charged. Velocity is vi cap, magnetic field is bj cap. Now for putting all the values in this formula, F is equal to q v cross b. So q will be minus E, v will be vi cap, b will be bj cap. Now v and b will come out, so it will be minus evb I cross j. I cross j is k cap. So force will be evb in negative z direction. So you have to remember how to use this formula, how to put the units. You have to remember all these things. Okay, so what are the conditions when magnetic force can be zero? Now we know that value of force is qvb sine theta, and we want to know the conditions when force will be equal to zero. So first condition can be q equal to zero. So if there is no charge, it means the particle is neutral, and on neutral bodies magnetic force is zero. Second condition is v is equal to zero. It means if suppose the particle is not moving. So if the particle is not moving, its velocity will be 0 and force will be 0. We have already learned this. That force is applied on moving charges. Third, suppose its magnetic field is 0. So if magnetic field is 0, then who will apply the magnetic force? So if B is 0, then definitely F will be 0. It will be common sense. And the fourth is suppose sine theta equal to 0. Now sine theta will be 0 in two cases. When theta is 0 degree, when theta is pi. So always remember, when V and B are parallel or anti-parallel, force will be equal to 0. Now we have to find out the conditions when force is maximum. So F is qvb sine theta. Since qvb are constant parameters, so if we'll change sine theta, then see how force will change. So force will be maximum when sine theta equal to 1, and sine theta will be 1 when theta is equal to pi by 2, or theta will be equal to 3 pi by 2, that is 90 degree or 270 degree. So force will be maximum when V and B are perpendicular to each other, and force will be 0 when V and B are parallel or anti-parallel to each other. Okay, so to remember all these conditions. Now what you have to do is you have to submit a quiz that I am sending it to you with this video. Please learn from this video. If you have any doubt, you can WhatsApp me. Okay.